Hello ladies and gents, Daniel here for Rock the JVM, and this video is about general type projections in Scala 2 and Scala 3. In particular, I'm going to talk about why general type projections were removed in Scala 3. And as such, I'm going to assume that you're already comfortable with inner types and type members in Scala, and I'll ask that you code with me in this video if you want to see how code compiles or doesn't compile. So I'm going to show you various examples here. And whenever you need to refresh your memory about this concept, if you ever want to use this feature in Scala 3 and figure out that the code does not compile, you may want to refer back to the video or to the written form at the blog with the link in the description, or to the newest Scala 3 new features course here at Rock the JVM, which also explains this concept in depth. Alright, amazing. So here in this video, I'm going to have two projects, one built with Scala 3 and one built with Scala 2, because we're going to compare the code between Scala 2 and Scala 3. So I'm going to navigate in between these two, but you're going to figure out which project I'm in by the suffix Scala 2 or Scala 3. Alright, cool. So what's a type projection? I'm going to define a small class. I'm going to call this outer, and another class, and I'm going to call this inner. And you probably know from Essential Scala that each instance of outer has a new kind of class inside its own scope called inner. So if I define, let's call this O1 as a new outer and O2 as a new outer, each of these instances has its own definition of inner. So if I define, let's call this I1 as O new O1.inner, O1.inner is a different type than O2.inner. So these types, O1.inner and O2.inner, are different. So I cannot really equate these two or do any sort of operations of these two. However, all the inner types are subtypes of outer hash inner, which is called a type projection. So this is the parent of all the possible inner types given by all the possible instances of outer. So this is pretty useful when we work with inner types that are nested inside other classes, traits, or objects, and they're very, very cool. The problem is that in Scala 2, type projections based on the outer type that is itself abstract is not allowed. And I'm going to give an example here in the Scala 2 project to demonstrate why that's the case. In the meantime, between the signaling of this problem by Martin Andersky on GitHub, that particular example does still compile in Scala 2, but I'm going to give another example here to demonstrate why type projections in the general sense are unsound. That means that the code should not compile, but it does, and it gives you some runtime errors. I've personally used general type projections in my quite advanced type-level programming mini-series here on Scala. I have a series for Scala 2 and one for Scala 3. They're quite different, so you might want to check those out. And in the advanced Scala 2 course here at Rock the JVM, I gave an exercise to practice path-dependent types and type projections in this sense. And the exercise sounded like this. I wanted to define a trait. I'm going to call this item-like, to describe an item that I might want to store in a fictitious database. And this would have a type key to be able to identify this particular item. So this is an abstract type member. And I'm going to define another trait. I'm going to call this item k, which is itself generic. And I'm going to extend item like. And I have my type key, which is an abstract type member, equals the k, which I'm using to define the item generic. Use this trick with the abstract type member equals the generic type argument in the type-level programming mini-series on Scala 2 to be able to resolve some types at compile time. Now, I'm going to define a class. I'm going to call this string item, which extends item string, and a class called int item, and this extends item int. So let's say I want to store strings or ints in the database, and I'm going to define a method called get. And the exercise asked for the signature of the method get so that I might want to pass a key as an argument to get, and I might want to return the actual item type for which that key was defined. So for instance, if I want to call get on a string, on Scala, I want to return a string item. So this will return a string item, and get on the number 42 should return an int item. And I want this method get to be super type safe. So if you add some generic type arguments, you should not be able to do type mismatches. So for example, you want to say get for an int and then you pass a string, that code should not compile. And the solution to that exercise was something along the lines of, let's call this I for item type, which is a subtype of item like. And I'm going to pass a key, which is I hash key, because I, being a subtype of item like, it must have the type key defined. So there is the path I hash key, and this will return the type I for which that key was defined. So this would be the signature of get. And in this case, the compiler would say, if I say get for the type int item, which is an item of type int, and I pass the number 42, this is correct, and this would return an int item. A get for a string item, and I pass the string Scala, this will also work, but if I do get on string item and I pass, for example, a number, this is not okay, because string item must have a key which is equal to string, and therefore the number 55 is a type mismatch. So this is what the exercise wanted you to do, to define this signature of the get method that would work in this way. Now, if you weren't recently exposed to abstract type members, abstract type projections, and so on and so forth, this exercise might seem a little difficult or a little contrived, but this exercise made sense in the context of the Scala 2 advanced lesson in the course. Now, this particular approach with the general type projection or abstract type projection works in Scala 2, but it should not in all cases. I'm going to give you an example where this sort of general type projection will compile the code and it will trigger a runtime error. So extending this exercise, for those of you who know the exercise from the Advanced Scala 2 course, I'm going to extend it here with quite a degenerate case. I'm going to define a trait. I'm going to call this item all, which extends item like with the type key here, and I might want to override the type key to be a supertype of any, and this restriction is both trivial because there is no supertype of any, and also a little contrived, but I want to show you something. And I'm going to define a trait. I'm going to call this item nothing, which extends item like, and I'm going to override the type key to be a subtype of nothing. In the exact same case, the type restriction is trivial and also a little bit forced. But I'm going to show you something where the inclusion or the extension of both these traits will trigger some runtime errors. And let me give an example. I'm going to define something that I'm going to call function all that will take a type argument. I'm going to call this I, which is a subtype of the first thing, which is item all. And because this generic type argument I is a subtype of item all, it must have an abstract type member called key, which is a supertype of any, and therefore key is equal to any. And so I can define this function, which is an any arrow I hash key, which is again equal to any. There's nobody preventing me from defining this function, and I'm going to call this x arrow x, the identity function. So any to any is available to me because I hash key must be the same as the any type because I is a subtype of item all. At the same time, I'm going to define another function. Let's call this func nothing, which takes the type argument I, a subtype of item nothing. And because I is a subtype of item nothing, the type key here is nothing because the subtype relationship is enforced here in the definition. So I can return a function that says I hash key to nothing, which is the identity function as well, x arrow x. So at this point, I hash key is any, which is replaced by the compiler, but I'm going to leave it at that. And in the second case, I hash key is nothing because there's the type restriction here. All right, now I'm going to combine both of these. I'm going to say function, I'm going to call this function weird, which takes a type argument I, which is a subtype of both these traits. So I'm going to say item all with item nothing. In theory, there's nobody preventing me from mixing both of these traits together, but notice that the type restrictions for key are incompatible. One is a supertype any and one is a subtype nothing, but there's nobody preventing me from writing this type, from defining it, even though there's no possible class that might extend both of these traits. And this will be a function from any to nothing, which combines both of these functions. So I'm going to say func all of type I, and then I'm going to say func nothing of type I. There's nobody preventing me from combining two identity functions. So in essence, I'm returning the same value, but notice that the signature of this function is any to nothing, which is very, very weird and cannot possibly be called. However, the code compiles. So if I compile this code, notice that the compiler doesn't give me any kind of compilation errors, which it should. And the reason why the compiler allows me to compile this code is that it does not resolve I hash key to a concrete type being just based on the bounds that I gave it before, key supertype any and key subtype of nothing. So the compiler was not smart enough to infer the fact that there is no possible item all with item nothing because I defined them earlier. The compiler would have had to store much more information to be able to figure out the incompatibility of these two traits. But given the fact that I have funcWeird here, and if I define a main function, so if I write main, I'm going to define an int, which is an int. I'm going to call funcWeird with a string Scala. And this is possible because funcWeird is an any, and it returns a nothing, and nothing is a subtype of int. So this declaration is theoretically correct, and if I do a print line, let's say an int +1, this will crash because funcWeird will return nothing in the very end, and if I try a +1, this will crash. So if I run this code, notice that, okay, I have a not implemented error from the get thing. I'm gonna comment these two out, and let me run this again. And this is the error that I was looking for. This is a class cast exception. The Java-lang string cannot be cast to nothing. So funcWeird is in theory an identity function because it's the combination of two identity functions, but it must be cast to nothing because that's what the function is supposed to return. So this string, which is passed between these two functions, is attempted to be cast into nothing, which triggers a runtime error. And the whole reason is the ability to say I hash key where I, the type, the generic type argument, is abstract. Because it's abstract, this blocks the compiler from making any inference about the type I, even though I had added some type restrictions here, so type bounds, but the space of possibility is so large that the compiler cannot possibly make this inference for any kind of type I. Of course, if I try doing this in Scala 3, even up to the get method, which has a single general type projection, it will not work, and the compiler error is very descriptive. So if I try compiling this in Scala 3, it will say I is not a legal path since it is not a concrete type. That is to say that the type projection of an abstract type, so an abstract type projection, is not allowed in Scala 3. Alright folks, there you go, an explanation for why general type projections were removed in Scala 3. Now I explained this concept and many others in more detail in the Scala 3 new features course which I've just released. So if you're interested, you can go check that out. And if you like this video, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on LinkedIn and Twitter for fresh updates on upcoming material. And check out the Rock the JVM website. I have tons of material about Scala, Akka, Apache, Spark, and everything in the Scala ecosystem at rockthejvm.com. Until next time, folks, I'm Daniel, signing off.